All right, welcome. So today's lesson is on positive rational exponents. It's section 7.7 in your textbook, so if you need to look back. I have written the homework here on your worksheet, and it is right here, so please make sure that you complete that tonight. Hopefully you were completing your warm-up as your computer was logging on. So what we're going to do now is we're going to go through the answers. Okay. If you can't tell here, this is actually a plus sign, so I'm sorry if you couldn't tell. All right, so this is all review. These are questions that are going to be on your test. So the first thing that I see here is I see 7 squared. So I'm going to just write 7 squared. And the next part, now a to the fourth and then to the second is a power to a power. So that's when you multiply. So we're going to have a 4 times 2. This is all my first part. Now my second part, I have 6 to the third. And then I have b to the third, and again, that's when you multiply. And now over here I have b to the second times the third, or to the third. And now I simplify. So 7 squared is 49, a to the 8th times 216, because that's 6 to the third, a to the 9th, b to the 6th. Now the only ones I can combine are the 49 and the 216. When I multiply those, I get 10,584. And then I can combine the a's, a to the 8th and a to the 9th. Now when they're being multiplied like this, you add the exponents. So we get a to the 17th. And then the last one is just the b. There's nothing to combine with it, so we just rewrite it. So that is your final answer there. All right, now we're going to do the second one. Now the first things first is you have to simplify this numerator before you even start dividing. Gotta get rid of the parentheses. So again, these are powers to power, so you multiply. X to the 6th, y squared. All over, and I'm just going to rewrite. Now it is a quotient problem, so I'm just going to start by making a fraction bar, and I decide what should go in the numerator and what should go in the denominator. Now let's see. First we have 6 minus negative 3. Well, 6 minus negative 3 is a positive 9. So since it's positive, I'm going to put it in the numerator. My next one, I have 2 minus 4. 2 minus 4 is a negative 2. So since it's a negative, I put it in the denominator, and then I put 2. The negative just tells me whether it should be in the numerator or the denominator. Remember, numerator is all positive, denominator is negative. But I should never have any negatives in my final answer. So there you go. All right, here's your objective for the day. Students will learn the properties of positive rational exponents in order to simplify and solve equations involving positive rational exponents. Remember, simplifying just means rewriting. We're just going to change what it looks like. Solving, you're actually going to get like x equals a number. Okay, so just to make sure that you know the difference. So please write that objective down in your blank. I would pause this so that you have time to do it. But I'm going to keep going on. Okay, so here's a table. Remember, this whole unit is about exponents and powers. So what we need to do is we need to make sure that we know this chart, okay? I'm not going to make you memorize the chart, but remember, there are parts of your test that you cannot use a calculator. So having some of these memorized might actually help you so you don't have to solve it down each time. I'm going to just fill it in. This chart is pretty useful if you want to look back to it. So 2 squared, 4. 3 squared, 9. 4 squared, 16. 5 squared, 25. 2 cubed is 8. 3 to the third power is 27. 4 to the third power is 64. 5 to the third power is 125. 2 to the fourth power is 16. 3 to the fourth, 81. 4 to the fourth, 256. 5 to the fourth, 625. 2 to the fifth, 32. 3 to the fifth, 243. 4 to the fifth, 1024. 5 to the fifth, 3,125. Okay, so there's your table. Now remember, the same thing works. The square root of 4 is 2. The square root of 9 is 3. So it kind of works backwards as well. Now remember these. The cubed root of 8 is 2. So that's going to be the important part here. Okay, so now we're going to go over the definition of nth roots. Now, I'm going to write the definition up and then we'll kind of go over about what it means. An nth root of x is written as this, n and then x. Okay, so n stands for the root. So usually it's a 2, and usually there's no number there because 2 is kind of implied. And then we have the root symbol and then just the number. So sometimes this in the n might be a 3, a 4, a 5. Usually those are the highest numbers that we're going to do now in this unit. So instead of just 2, we're going to put a 3 here, a 4, and a 5 here. Now to do that, you have to know how to type it into the calculator. So what I did is I put a couple screenshots up here so that you know. The main part is to always type n first. So I'm going to just write that first. Type n first. Okay, and remember, n is just going to be a number. It's going to be 3, 4, 5. You can do 2. It's fine. And then you're going to hit the math button, as you'll see up here. So then you hit, and this is an actual button on your calculator. It's over to the left. Okay, and then you're going to get this screen right here. Okay, now the one that we are worried about is actually this one, number 5. Okay, so you're going to hit math, and then you're going to hit the number 5. And that's going to give you the x and then the square root. The reason we put the number first is because it's going to be, if we want 5, the 5th root, it'll put a 5 there for us. And then you just type the number in. So, for instance, if we're doing the 4th root of 64, this is how it would look on your calculator. And then it'll give you the answer. So that's what you're going to be practicing a lot today, and how to actually solve all of these. Our next part, here's some examples. So I'm going to rewrite them, or I'm going to type it into the calculator, and I'm going to get an answer. Now again, here's how it's going to look on the calculator, and then I'll just tell you the answer. Make sure you're trying it so you're getting what I'm getting. So you're going to type 3, and then on the calculator you're going to get x, and then a root symbol of 23. Now when you get that, the final answer is 3. Okay, next part. 4, and then the math number 5, 81, and you should also get 3. 4, math 5, 625, and when you solve that out, you get 5. Next one, 4, when you hit math 5, again that button comes up, and then you get 2. So this part right here is all from the calculator. Okay? But this is the answer. Okay. So next one, we're going to learn another theorem. So sometimes these are going to be, sometimes variables are going to be raised to a fraction. So here's what this theorem is. It's the 1/2 exponent theorem. So when x is greater than or equal to 0, and n is an integer greater than 1, now here's the important part here. We have x, 1/n, and here is how it's translated to an actual root symbol. Whatever number is in the denominator goes outside, and then inside we have our number raised to the first power. So I'm going to do some examples with you. Alright, so we have 81 to the 1/4 power. All these fractions are to the power. I know I tried my best to make it actually look like that. So, here's how you rewrite it. 4 to the 81 power to the first. Okay? Now, we'll see where these 4s and 1s come in. 4 is in my denominator, so 4 goes down here. 1 is in my numerator, so it goes over here. 81 is just my base, so that goes inside the exponent. So when you actually solve that out, which I think we did on the previous slide, my answer is simply 3. All right, my next one, I'm going to rewrite it again. Okay, so my 5 is my denominator, so that goes numbers outside my root, and then I have 243, and then I'm going to raise it to the first power. So raising it to the first power just means it's going to stay the same. So when I actually do that out, I get an answer of 3. My next one, I'm just going to rewrite it first. My denominator for this one is 2, so that number goes outside of my root. Now this one has this crazy negative out here. Let's put it on at the end. I'm just going to put it to the outside right now. I have my 4 inside, but I have my 1 here, so I'm going to raise it to the first. So if I do the square root of 4 to the first, I just get 2, and then I bring down the negative. So its final answer, -2. Alright, these are 6 problems that you're going to do by yourself again. Solve it exactly just like I did the example. Practice doing it without a calculator. A lot of these are going to be on the part with non-calculator on your test. You can check your answers at the end, and then we'll move forward and see how you did. So what I want you to do is, we have it written like this. Write it the other way. So I'll do the first one for you because we're just going to rewrite it the other way. We're going to make it have a fraction as the exponent. So my base is 23, or 27, excuse me. So I write 27 here. So it's raised to like the first power here, so that's my numerator. And then my denominator is 3, because that's the number out here. So I rewrote it like that, and the answer to that one is 3. Okay, you can try some of those by yourself. Alright, the next part is the rational exponent theorem. Now this one's a little bit different. It's a continuation of the last part that we just did. So, for every non-negative number x and positive integers here's what the power is. It's x to the m over n equals the nth root of x to the m power. So it'll look like that. Again, I'm going to go through some examples. Now, when it has variables, you don't get an actual answer, you're just rewriting it. When it has numbers, you get an actual answer. Let's go through this first one here. Okay, my base is y for this one, so that is what's going to be underneath the root button. Now my numerator is a 2, so that's always what this is raised to. So this is raised to the second power in here. And now my bottom number is 7, and that's what number goes down here. So I have the 7th root of y squared. And you can leave it just like that. Alright, my next one. Now my next one has numbers, so I'm going to actually get an answer. So first things first is I can write my root, and I can write my base inside. Now, my numerator is a 3, so inside here I have to raise the 25 to the third power. And then my 2 is in my denominator, so my 2 goes down here. So now it's the square root of 25 to the third power. So if I just simplify this part right here, I would get, sorry about that, I would get 15625, and I'm just taking the square root of it. So then when I type that into the calculator, I would get 125. So that's my final answer. Alright, my next one, again, all I'm doing is rewriting. So I have the square root of t. My denominator is the 5, so that's what goes out here. My numerator is the 4, so that's what goes over here. Okay, that's all I had to do for that one. My next one, I have 16, so it's the square, or the root of 16. The denominator is 4, so that's what goes out here. My numerator is 3, so that's what goes over here. If I solve that out, 16 to the third power is 4,096. But I still have to take the fourth root of it, and remember that's how you use the calculator, and that equals 8. So here's some practice problems for you to do as well. Again, you can check your answers at the end. Alright, so now we're going to put all of it together that we've done. We're going to put the numbers and the variables all together. So what I do is I'm just going to create two separate problems for myself. The first one is going to be 27 to the 4 over 3. And then the second one is going to be x to the 6 times 4 over 3. Now we should be able to do this one already pretty well. We have 3. Just going to rewrite it like that so I could type it in my calculator. Now this one over here, remember, it's like a 1. So 6 times 4 is 24 over 3. The third root of 27 to the 4th is the third root of 5, 3, 1, 4, 4, 1 times x to the 24 divided by 3 is 8. So when I solve all of that out, the third root of this number is just 81, x to the 8. So I have 6 for you to try here, so try those and you can again check your answers at the end. Alright, now what we're going to do are we're going to solve equations with positive rational exponents. First step is to isolate the variable. Second step is to raise to the reciprocal on both sides. And the last step is to just simplify. So I got 2 questions here to do with you. Alright, I'm just going to rewrite it so I can write it a little bigger. So, I isolate the variable. The variable is already isolated. It's x is by itself. So I'm on step 2. Step 2 is raise to the reciprocal of both sides. Now my exponent here is 5 over 4. So what I'm going to do is I'm going to raise it to 4 over 5. And those are going to go away. So I'm going to have x equals 243 to the 4 over 5 power. And again, you can do that all in your calculator. I'm going to do it right here. X equals the 5th root of 243 to the 4th, which means x equals 81. My next one, I need to isolate first, so I'm going to add 4 to both sides. So I have y 2 to the 3rd equals 25 times 3 over 2 times 3 over 2. These go away. I'm just left with y equals 25 3 over 2. So I get y equals square root of 25 to the 3rd, which means y equals 125. Here are 6 more problems for you to do. Again, check your work at the end, and I want the whole packet at the end, and please don't forget your homework.